So find the Fourier transform of the function e raised to mod x minus of mod x, in fact, and hence show that minus mod s, and hence show that integration from minus infinity to infinity e to the power I lambda x upon 1 plus lambda square d lambda is equals to pi into e raised to minus of mod x. Is it okay? We have asked to find the Fourier transform of this function, and with the help of Fourier transform, show that this integral is equal to this. Okay, is there any doubt with the question? Is there any doubt with the question? We have asked to find the Fourier transform, right? So before start with the actual solution, let me again recall the formula. Just now we have recalled, but still to solve this example, we have asked to evaluate the Fourier transform, isn't it? We have asked, we have not asked in particular find the Fourier transform or find the Fourier sine transform or Fourier cosine transform. So the choice is our, isn't it? Either we can check the nature of this function, nature of the function f of x is equal to e raised to minus of mod x, and if the function is even, then we know we use Fourier cosine transform, isn't it? And its integral. If the function is odd, then we use Fourier sine transform and its integral, right? So here, either we can check the nature, or since we have asked to find the Fourier transform, directly we can use the formula of Fourier transform, isn't it? So what is the formula of Fourier transform? Fourier transform. What is the formula? Yes. What is the formula of Fourier transform? F of lambda equals to, yes, f of lambda. Fourier transform is denoted by function of lambda, isn't it? Which is integral from minus infinity to infinity f of u e to the power minus or plus there?
Minus.
Yes, minus of I lambda x du or d lambda? Du. These are actually the points of confusion, whether to consider the exponential term, that is e raised to minus of I theta or e raised to plus I theta, and whether to consider the limits of integration as a lambda or u. So that is why I'm asking to you. So here, this is the formula to find the Fourier transform. All right. Now, as we have given the function in terms of x, and since this is definite integral, we can change the variable of integration. But if we change the variable of integration, we may get confused here in this x, isn't it? E raised to minus, I think it is u here, na? Right? E raised to minus I lambda u du. Is that okay? So here we can change the variable of integration. Or if you are confused, we can, since we have given f of x, we can write its f of u there, isn't it? Now, before substitution of the function, let me ask you, in show that part, this integration is with respect to lambda. That means what we have to show with respect to lambda means whether it is Fourier transform or integral, it is, this is integral, right? Because it is with this integration is with respect to lambda. And as I said, if the integration, if the right hand side integration with respect to lambda, then that will be a Fourier integral, isn't it? And if the right hand side is integration with respect to u, then that will be a Fourier transform, isn't it? So actually we have asked to show that the Fourier integral value is this. So once we get the Fourier transform, we need to substitute this transform into its integral. So let us write the formula of integral here. What is the formula of Fourier integral representation? Fourier integral representation, or just simply we can write, we can say Fourier integral is, yes, what is the formula of Fourier integral? F of x is equals to 1 upon 2 pi integral from minus infinity to infinity, right? F of
Lambda
f of lambda e to the power plus or minus. Now it is plus here. We have written here minus.
plus.
So plus I lambda x, isn't it? And d lambda. So if we compare this and the required integral, we can easily get that we have here e raised to I lambda x, isn't it? So f of lambda must be like this, 1 upon 1 plus lambda square. In fact, indirectly we have given the answer also, the Fourier transform, that f of lambda is 1 upon. We have to get that f of lambda actually, isn't it? And we have to show this integral is equal to, when we take this 2 pi to the left hand side, we'll get this, isn't it? So first of all, we have to get the value of f of lambda, and we have to substitute that value into this and get the required result. That is what this is. So in earlier pattern, this question was asked for 4 marks. Now it can be asked for 5 to 6 marks in this 2019 pattern, which is very important. All right. In earlier pattern, either it was asked to find the Fourier transform, or find the Fourier transform, or find the Fourier integral. Now here in 2019 pattern, the question may ask like, find the Fourier transform and hence show that. So that is why it is, because as it is lengthier, it will be asked for 5 to 6 marks, isn't it? So let us start with finding the Fourier transform. We have written the formula, so substitute the function there. So therefore, I hope board is visible. F of lambda is equal to, is this visible?
Yes, sir.
F of lambda is equals to integral from minus infinity to infinity, f of u, let me write the formula again, f of u e raised to minus I lambda u du. So should I change the variable of integration here? Yes, I can change, isn't it? Because as it is definite integral, I can change u to any variable, isn't it? So for our convenience, as we have given the function in terms of f of x, I am writing this formula in terms of f of x. But please don't get confused with this f of x and this f of x. This is Fourier integral, isn't it? And here I am changing this u to x for my sake of convenience, isn't it? For the simplicity purpose. So that is integral from minus infinity to infinity, f of x e raised to minus I lambda x dx. Wherever u is there, I have replaced it with x. Please ask if any confusion. Isn't it? Why I have replaced u with respect to x? Because I can directly now substitute f of x, given f of x, directly here. Isn't it? Now, if you look at this f of x, what we have given, f of x is given to be e raised to minus of mod x. So can we substitute this f of x directly here? No. It is depends on again mod, isn't it? Because here we have given the two-sided interval minus infinity to infinity. So we actually have to specify this function in those intervals, in positive as well as negative. So let us write this function f of x is equal to, it is, what is the definition of mod x? Mod x is positive x in, or mod x is plus x in x positive interval, right? And mod x is minus x when x is negative, is it? So this will be positive. So e raised to minus of x when x is greater than or equal to 0, right? And this mod x is negative, minus x, minus plus x. Please try to get the definition. Plus x when x is negative. Now here you can see that I have included 0 here and I have excluded 0 from here. All right. So this is the definition of given function actually. So let us write, first of all, let us write this function in terms of interval, because then only we'll be able to substitute the function. So e raised to minus x, is it visible? E raised to minus x when x lies between, x is greater than 0 means what? What is the interval there?
Positive.
Positive means what? From where to where?
0 to infinity.
0 to infinity, correct. So x lies between 0 to infinity. All right, that is the interval. And e raised to plus x when x is, or minus infinity is less than x is less than infinity. Is it clear? Please ask if any doubt. Okay, so where is the tester? All right. So let us substitute these two functions here. We have to split this interval minus infinity to infinity according to the function, according to our requirement. So requirement is, therefore, this f of lambda will be e raised to integral from minus infinity to 0, all right? F of x e raised to minus I lambda x dx plus integral from 0 to infinity e raised to minus, sorry, f of x e raised to minus I lambda x dx. Is it okay with this step? What I did, I have splitted this interval minus infinity. See, you can see here minus infinity to infinity. I'm writing it as a sum of two integrals. How? Minus infinity to 0, like this. Union 0 to infinity. Please check. So the integral in this means integral in this plus integral in this interval, isn't it? That is what I'm doing here with the same integrand. Is it okay? Now in negative interval we know the value of function. In positive interval we know the value of function. Let us substitute. Therefore, I'm writing since. Therefore, is it visible? So f of lambda is equals to, yes, integral from minus infinity to 0. What is the value of function? It is, in negative it is e to the power plus x e raised to minus I lambda x dx. All right. Please ask if any confusion. Integral from 0 to infinity f of x in positive interval. What is the value of f of x? It is, according to the function, it is e raised to minus x in positive interval. So that is why I'm writing here e raised to minus x, e raised to minus I lambda x dx. All right. And now our job is to evaluate these integrals and then substitute into its integral formula. That is the final answer. So evaluate these integrals now. You know very well how to solve such kind of integrations. Please ask if any doubt.
Sir, f of x is pi into e raised to minus mod x.
Yes.
Sorry, modulus of x. So pi नहीं देने का क्या?
Where is pi? Here you're asking.
हाँ?
That is, we asked to show that. We have to show that
Okay,
the
okay,
value of this
okay.
integral is this. F of x is the e raised to minus x minus of mod x only. Okay?
Okay, I didn't saw the upper one part.
Okay. Fx is e raised to minus of mod x. And then with the help of that, show that this actually. All right, so we have asked to evaluate Fourier transform first. So that is what we are doing. We have written the formula Fourier transform. And into that, we have replaced u by x. Why? You can write a line there that indefinite integral variables are immaterial. That is why we are changing u to x. Please note. Or it is not necessary to replace again. You can write f of u also. Then you have to write this f of x in terms of u. And then accordingly, you have to substitute into the integral. But to avoid all that, I have replaced u by x. It is not necessary again. All right. So evaluate these integrals. What will be f of lambda? F of lambda is equal to integral from minus infinity to 0. I can merge the indices. E to the power x minus I lambda x. If I take x common, then 1 minus I lambda into x, right, dx, and plus here integral from 0 to infinity e raised to, I'm taking minus x common, then inside it will be 1 plus I lambda into minus of x dx. Is that okay? I have taken minus x common here x. Now integration of e to the power ax, e to the power minus ax. So what will be integration of e raised to ax? E raised to ax upon a, that is 1 minus I lambda, with the integration minus with the limits minus infinity to 0, plus, please check the calculations, plus e to the power minus of 1 plus I lambda upon 1 minus of 1 plus I lambda, and the limits from 0 to infinity. Now substitute upper and lower limits. You can ask your doubts in chat also, chat box. So what is the function at upper limit? What will be the function value at upper limit? X is equal to 0. See, variable is x. So that is why we are substituting the value of x, not lambda, remember. Please don't get confused. So when x is equal to 0, e to the power 0 is 1. So 1 upon 1 minus I lambda. Minus function at lower limit. When x is minus infinity, e to the power minus infinity क्या होता है? E raised to minus infinity is? E raised to minus infinity is 0, right? So this will be 0. E to the power minus infinity function at lower limit. Plus, now this at the limits. Here it is x, na? Sorry. So when x is equal to infinity, this will be e raised to minus of infinity, and that will be 0. Minus this function at lower limit, that is x is equal to 0. So e raised to 0, so 1 upon minus of 1 plus I lambda. Please check the calculations and ask if any doubt. So what am I doing? 1 upon 1 minus I lambda minus plus 1 upon 1 plus I lambda. Please check. All right, 1 minus I lambda, 1 plus I lambda. So as we know, okay, I think you don't have discussed complex variables in M1, right? That part is excluded in 2019 pattern, M1 pattern. All right, anyways, always remember, if the complex number is there in the denominator, we have to take into the numerator by rationalizing the denominator. Always remember, complex number should not be there in the denominator. So to rationalize, or we can cross multiply here to take the LCM. What it will be? 1 into 1 plus I lambda plus 1 into 1 minus I lambda upon 1 minus I lambda plus into 1 plus I lambda. A minus B into A plus B. What it will be? A square minus B square. That is 1 minus I lambda square. That is I square lambda square. All right. But what is I square? I square is minus 1.
Minus 1.
Is it visible? I square is minus 1. So minus plus there. Isn't it? I'm writing here. So that will be, this will get cancelled. 1 plus 1, 2. 2 upon 1 plus lambda square. That is the value of f of lambda. Fourier transform. Is that okay? Please ask if any doubt. F of lambda is 2 upon 1 plus lambda square. 2 upon 1 plus lambda square. Two upon 1 plus lambda square. So that is what the required Fourier transform. Now we have asked to show that this integral. So what we are doing? We are substituting this value of Fourier transform into its integral. We know if f of lambda is Fourier transform, then what is its integral? Therefore, integral or Fourier integral is, what is the Fourier integral formula? F of x is equals to 1 upon 2 pi integral from minus infinity to infinity f of lambda. This is the simplified Fourier integral formula. F of lambda e to the power I lambda x d lambda. So just substitute this f of lambda there. 1 upon 2 pi integral from minus infinity to infinity f of lambda is 2 upon 1 plus lambda square e raised to I lambda x d lambda. All right, this 2 will get cancelled. And let us write the value of this integral. Let us take this 1 upon pi to the left hand side. Therefore, integral from minus infinity to infinity e to the power I lambda x upon 1 plus lambda square d lambda is equal to what? Pi into f of x. And what is f of x? That is, we have given. F of x is e raised to minus of mod x. So pi into e raised to minus of mod x. And that is what we have asked to show that. Is that okay? Please ask if any doubt. Fourier transform and its integral. Ask me your doubts, if any. If you have finished to write, then take the next question. I'm writing on the board. I'm writing in short now. Find Fourier transform. Find Fourier transform of the function fx is equals to cos x in the interval 0 to pi and it is 0 otherwise. I hope there is no doubt. If any doubt, please ask in the last example or in the formulas also. If no doubt, then start to find the Fourier transform of the next function given. See on the board. Find the Fourier transform of this function. F of x is given to be cos x in the interval 0 to pi and it is 0 otherwise. So is it clear that what the function have defined from minus infinity to infinity? Just try to write that function value. What is the function in minus infinity to 0 or what the function value in 0 to infinity? Yes? Are you able to write this function in terms of that? What is the main interval we are having? First of all, let me write the formula of Fourier transform. Fourier transform. What is the formula? You people are not replying actually. Not giving a proper response when I'm asking the questions. Anyways, f of lambda is integral from minus infinity to infinity f of u e to the power minus I lambda u du. Right? This is the actual Fourier transform. So how do I split this interval according to the function? Let me rewrite the function. We have given the function f of x as a cos x in 0 to pi, and the function is 0 otherwise. Otherwise का meaning क्या है बताओ मुझे? What this otherwise means? Hello? It means this is our number line minus infinity to infinity. So we have to break this number line according to the function given. So let us break, since we have given the function non-zero in 0 to pi only, this is our suppose 0. So in 0 to pi only, we have given the function value as a cos x, and 0 otherwise. Otherwise means in minus infinity to 0 also the function value is big 0, and in pi to infinity the function value is 0. Right? So therefore, we can break this entire interval minus infinity to infinity in terms of three parts. How? Minus infinity to 0, plus 0 to infinity, 0 to pi, plus pi to infinity. Isn't it? So let us write this interval according to the splitting. So therefore, f of lambda will be equals to integral from minus infinity to 0. I'm writing this u in terms of x, as in definite integral variables are immaterial. So f of x e raised to minus I lambda x dx plus integral from 0 to pi f of x e raised to minus I lambda x dx plus integral from pi to infinity f of x e raised to minus I lambda x dx. Is that clear? So with this, now let us substitute the function values. In minus infinity to 0, the function value is 0. So f of x is 0. Therefore, this integral will be 0. Right? In pi to infinity, the function value is 0. Therefore, this f of x is 0. Therefore, the whole integral will be 0. So only the middle integral will be non-zero. Right? So therefore, I'm writing here. Therefore, f of lambda is equals to integral from 0 to pi. What is the function value there in 0 to pi? Cos x. So f of x is cos x into e raised to minus I lambda x dx. So that is equals to integral from 0, I'm rewriting it, 0 to pi e to the power minus I lambda x cos of x dx. I just have written in standard form because we have we have the standard formula to evaluate this integration. E raised to ax cos bx wala formula. What that formula is? Integration of e raised to ax cos bx dx is equals to what? First of all, we'll write e raised to ax upon a square plus b square into, as it is cos there, I've given you the hint how to remember these formulas. As it is cos there, we'll start with a cos bx. So a cos bx, and since integration of cos is plus, so therefore plus sine plus b sine bx. Please check these formulas. A cos bx plus b sine bx is the standard formula. So let us use this formula to this integration. Therefore, f of lambda will be, what is a there? What is the value of a there? A is minus I lambda, right? And what is b? Bx
1.
is 1, right?
1.
So e to the power minus I lambda x upon minus I lambda square, a square plus b square 1 square into a, that is minus I lambda cos bx plus b sine bx, that is x, and this the whole from 0 to infinity. 0 to pi, not infinity, 0 to pi. Now substitute upper and lower limits. The function value at upper limit is e to the power minus I lambda pi upon minus I lambda square is minus I square lambda square, but minus I square or minus I square ka square will be I square, that will be minus, so minus of lambda square, so 1 minus lambda square, please check. All right, and inside it will be minus I lambda cos pi plus sin pi. This is at upper limit minus function at lower limit. So lower limit is 0. So e to the power 0 is 1 upon 1 minus lambda square into minus I lambda cos 0, which is 1, plus sin 0. Sin 0 is 0. Sin pi is 0. I hope you know that sin of n pi is 0 for all n natural number. In fact, non-zero or whole number, we can say n whole number, because sin 0 is also 0. And what is the value of cos of n pi? Cos n pi is 1 when n is even, right? Even means multiples of 2, and it is minus 1 when n is odd. So what the f of lambda will be equals to? F of lambda is, yes, sin pi is 0, cos pi is minus 1, minus minus plus, so I lambda e raised to minus I lambda pi upon 1 minus lambda square minus, this is 1, this is 0, so minus minus plus 1 upon 1 minus lambda square. All right, so that is equals to it is I lambda, na? I lambda, right? I lambda. And that is your final answer. We have not asked to show that or Fourier integral, so that will be your final answer as a Fourier transform. Please ask if any doubt. If you want to simplify further, you can, but I don't think that it will be possible to simplify further. Please ask if any doubt. Is there any doubt with the question or in any step? Is there any doubt? Yes, Abhijit Pole.
No, sir.
Okay. Right, next question, find Fourier sine transform. Find Fourier sine transform find Fourier sine transform of f of x is equals to, find Fourier sine transform of fx is equals to, one in the interval 0 to 1. Fx is 1. In the interval 0 is less than x is less than 1, and it is 0 in the interval x is greater than 1. Find the Fourier sine transform. So what we have asked to find? Fourier sine transform. So we'll start with the Fourier sine transform formula only. Don't get confused whether to start with Fourier transform formula or Fourier cosine transform formula. We have asked to Fourier sine transform, so we'll write the formula of Fourier sine transform only. What is the formula of Fourier sine transform? Yes? Any one of you? First of all, Fourier transform is denoted by f of lambda. So sine transform is denoted by f of lambda only. But with respect to sine, we have corresponding to sine we have s there. So fs of lambda. Yes, what is the formula of Fourier sine transform? Yes. Sine transform, integral from 0 to infinity f of u, sine or exponential? Very easy to remember that while writing f of lambda, everything will be in terms of u. If we are writing sine, then sine. If we are writing cos, then cos will be there. All right. So let us write in terms of x. Integral from 0 to infinity f of x sine of lambda x dx. Now let us split this interval 0 to infinity according to our function. See, always remember there is one more point of confusion, that whether to write these limits with from minus infinity to infinity or 0 to infinity. So always remember, while writing the formulas of Fourier transform and its integral, the limits are from minus infinity to 0. While writing the normal general Fourier transform and its integral, we are writing the limits of integration from minus infinity to infinity. And while writing the Fourier sine transform and its integral, or Fourier cosine transform and its integral, we are having from 0 to infinity, the limits are. So don't get confused with this also. 0 to infinity. So we have to consider only the positive part of that interval. That is what we are having, positive 0 to infinity. So whatever the function defined, we have to consider the function value in positive part only. Suppose if our function is defined in minus infinity to infinity, but our actual interval is 0 to infinity, isn't it? That is what our boundary is. So we have to consider the function value in that boundary only. Just skip the other value of the function, isn't it? So I can split this in function. Let me write like this. This is suppose minus infinity to infinity. But since my limit, my boundary is 0 to infinity, so I'll skip first of all this 0 to infinity. And now in 0 to infinity, how my function is defined? So the function is defined in 0 to 1, 0 to 1, and then 1 to x is greater than 1 means 1 to infinity. So in 1 to infinity, the function value is 0, and in 0 to 1, the function value is 1. Very easy. All right. So let us split this 0 to infinity interval according to the function. How to write? Therefore, f of lambda, fs of lambda that is Fourier sine transform, is equal to integral from 0 to 1 fx sine lambda x dx plus integral from 1 to infinity f of x sine of lambda x dx. Substitute the function's value now. 0 to 1, what is the function value? 1. So 1 into sine lambda x dx plus in 1 to infinity the function value is 0. So integration will be 0, isn't it? And what is the integration of sine lambda x? It is minus cos of lambda x upon, what is the variable of integration here? X. So lambda is constant. Later we are going to discuss the examples where the integration will be with same integration, but that will be with respect to lambda. So in that case, x will be constant, isn't it? So I'll repeat that again while discussing. So here integration with respect to x, therefore lambda is constant, so that will be in the denominator upon lambda and from 0 to 1. So substitute upper and lower limits. So at upper limit it will be minus cos of lambda upon lambda, and at lower limit it will be cos 0, which is 1. So minus, and this minus will be plus 1 upon lambda. So the required Fourier transform is f of lambda is equal to 1 minus cos lambda upon lambda. Please ask if any doubt. Okay, so I think it's 10:56. We should stop here. I don't know whether to continue with the same link or you have the different link. Okay. Let me ask first of all to Rupali ma'am whether to continue with the same link or what. Don't leave the link. Okay. Hello. Actually, Rupali ma'am is not going to take lecture. I was thinking to take lecture, but most of the students have left the meeting. Anyways.